Hello ladies and gentlemen, welcome to the screencast for evaluating limits by using the conjugate. So we're going to start off by evaluating this limit as x approaches 4 using direct substitution. Excuse me. So when we substitute the 4 in for the x into the function and we evaluate that, we get 0 over 0, which as we recall is the indeterminate form of evaluating limit. So when direct substitution doesn't work, we have to use the conjugate to manipulate the function. So the conjugate is a two-term expression, the same as the original, but the sign has been switched. So if we look at that function again, the limit as x approaches 4 of square root of x minus 2 over x minus 4. The conjugate of the radical portion is square root of x plus 2, and so we're going to multiply this function by 1, and radical x plus 2 over radical x plus 2 is 1. So when we do the multiplication, your numerator is square root of x minus 2 times the square root of x plus 2, and the denominator is x minus 4 over square root of x plus 2. So we multiply out the terms in the numerator. Square root of x times square root of x squared, plus 2 radical x minus 2 radical x. So if you notice what happens here, they'll cancel out. And negative 2 times 2 is negative 4. And the denominator, don't multiply it out. Just leave it as those two binomials, and you'll see why in a second. So please don't multiply them out. When we clean up the numerator, since 2 radical x and negative 2 radical x cancel each other out, and the square root of x times square root of x is x, your numerator is x minus 4. The x from there and the minus 4. And we had an x minus 4 in our denominator. So what will happen is the x minus 4's divide out, and you'll wind up with 1 over the square root of x plus 2. Now we go into direct substitution mode, and you put the 4 in where the x is. So the square root of 4 is 2, and so you have 1 over 2 plus 2, or 1 over 4. That's the limit of the function. The limit of this function is 1/4. So let's take a look at another example. If we look at the function, we want to evaluate the limit as x approaches 9 of this function. Square root of x minus 3 over x minus 9. And when we evaluate that, we have an indeterminate form of 0 over 0. So now we're going to multiply by the conjugate, radical x minus 3. The conjugate is radical x plus 3 over itself. So if we take a look at what happens, if you look at the previous example, the radical x plus, there were 3 radical x and negative 3 radical x cancel each other out, and basically all you have is the square root of x times square root of x, which is x, and negative 3 times 3, which is 9. So what I did here is I took a little shortcut, but if you need to go back to the previous problem, and you'll see how the multiplying out of those terms follows. So you wind up with x minus 9 over x minus 9 times radical x plus 3. So the x minus 9's cancel, and you will have 1 over radical x plus 3, and I substituted the 9 in there. So you have 1 over radical 9 plus 3. The square root of 9 is 3. You have 1 over 3 plus 3, or 1 over 6. So again, if you need to go back to the previous problem to see how the numerator with the conjugate simplified, go do that. So take a look at this next problem. This one is x minus 7 over the square root of x plus 2 minus 3, and we're looking for the limit as x approaches 7. So when we do a direct substitution, what a surprise, we have an indeterminate form, as if we couldn't have predicted that already, right? So we have to multiply by the conjugate. So the conjugate in this case is square root of x plus 2 plus 3 over itself. So in this case, the denominator is what gets simplified, and you wind up with the square root of you wind up with x minus 7 as your denominator. So when we do direct substitution, you have the square root of 7 plus 2 plus 3, or the square root of 9 plus 3, and the square root of 9 is 3, so the limit of this function is 6. So if you need to go back and double check, see how the multiplication of the conjugate plays out. So if you notice in this problem, I put the term in the denominator that needed the conjugate instead of the numerator. So it will be the term with the radical, and it could be in either location. That's why I gave an example in this instance with the denominator. So take a look back at this, replay it again if you need to, and I will see everyone in class, and we'll be entertaining questions on the screencast, and then we'll be doing some practice problems in class. So thanks for tuning in.